Hi, my name is Randy Becker. I'm an application engineer with Keysight Technologies. I'd like to give you a quick overview of Keysight's latest vector signal generators and vector signal analyzers. These are perfect for anyone that's doing work on 5G, particularly new radio, where we want to do things with beamforming, spatial multiplexing, transmit receive diversity, as an example. Or people that are doing component measurement, say on a power amplifier, where people are very concerned about measuring EVM and ACLR. I'll start over here with in my demo setup on the new M9484C microwave vector signal generator. Now this is a completely different source in the industry. Nothing like it has ever been done before. It's based on an all direct digital synthesis architecture, giving unparalleled signal purity and accuracy. And I'll do a couple of demos to illustrate those points. Also in this new platform, we've extended the frequency range up to 54 gigahertz with up to 2 channels in a chassis, and further, those frequencies can be extended all the way to 110 gigahertz by using one of these remote heads that can be connected to the front panel here. So this allows positioning the test equipment right near where you need to make the actual measurement. So of course this has a 1mm connector on it to support those frequency ranges. Also in this platform you can get 4 channels in a chassis with frequency coverage up to 20 gigahertz. So there's a lot of great new functions and capabilities in this generator. In this simple demo, I've connected the output of one channel to the input of the spectrum analyzer, and I'm generating a simple multi-tone signal that has been offset in frequency so that we can see the images that might result from generating such a signal. Now, because this generator does not have an IQ modulator in it any longer, it does not have any of those imperfections that come with an IQ modulator. Although that was a fantastic device for simultaneously controlling both the amplitude and phase of the carrier, we no longer have that here. So if we look at this multi-tone signal, you'll see that there are no images and there is no LO feed through. You can see a notch here. I did create a notch in the signal, and you can see that in fact we have no spurious or images in the notch. If we move up to the upper part of the screen, this was the same measurement but done on a traditional vector signal generator using an IQ modulator. And very clearly you can see the images that result and also the high amount of LO feed through at the center frequency. Additionally, you would also note there's quite a bit of undesirable spurious content outside the channel. So by looking at these two screens, you can definitely tell these are completely different, and then in fact, this new generator is a leap in signal generator technology. So the next question is, you might wonder, well, what can I do with that extra dynamic range? Because we're not limited here by the images. Normally you'd think, yeah, I've got this much dynamic range, but clearly you're limited here by those images. And I'm going to make a couple of EVM measurements to illustrate those points. So I'll come to the generator and I'm going to generate a single component carrier new radio signal. I'll launch the VSA software, and you see the measurements on the screen. So there's a lot of different measurements being made here. On the center far left, we can see the spectrum. So the bandwidth there is just over 100 megahertz. You see in the upper left the constellation diagram, which is 64 QAM. So this is 100 megahertz component carrier with 64 QAM modulation. You also see the 3D view of power versus frequency and time. And here we have the overall EVM of this signal, which is right at 0.2% EVM. A fantastic result since we are doing this at 28 gigahertz.